In this video, we're hopefully going to teach you the 20 amino acids in 20 minutes or less. So the way we recommend using this video is to pause it frequently and draw these structures out as you're going along, and then go back to the beginning of the video and do it 2 or 3 times. And the people that we've tested this on in our review group swear by it. It'll really help you out, we think. Well, let's see. Pointers. One thing is we're not going to be teaching any amino acid chemistry or anything in this video. It's just going to be remembering and memorizing the structures so that you can picture it quickly in your head and be able to answer questions about whether it's going to be polar or non-polar and all these kinds of things. So to begin with, the things that you're going to need to know before we start are going to be at least the 1-letter symbol for each of the amino acids. It'll help to note the 3-letter abbreviations sometimes, although these are much easier to remember because they sound pretty much like the name of the amino acid. Although for some of the single-letter abbreviations, if you don't already know, oops, that's not a good case. Tryptophan, for example, is symbolized by the letter W instead of T because that's threonine, and there's a couple of those to keep an eye out for. So I'll give you a second so you can pause this real quick and memorize these. All right, so you got to memorize. And to start with, we of course have our amino acid background where we have the amino terminal and the carboxylate terminal. So, of course, the easiest amino acid is glycine, which, of course, its side group is just 2 hydrogens. That's it. No shortcut there. It's simple, easy. You just have to memorize it. Every single other amino acid, aside from glycine, has a beta carbon. So if you're not familiar with the terminology, this carbon right here is the alpha carbon, and all other amino acids have at least this beta carbon right here. So we're now going to call this whole structure our backbone for building amino acids. So when you add just the methyl group, so we have just the CH3 right here, this is alanine. That one you're also going to have to just memorize. No real shortcuts there, but it's nice and simple. The straight backbone, just think of it that way, is alanine. From now on, all of our other amino acids are going to build off of this backbone. So we'll start with valine, and its single letter abbreviation is V. And I know some of these are going to be really moronic as they're so simple, and I know you've all thought of these, but hopefully seeing them all in one place will help. So valine, its single letter abbreviation is V, and we just add a V to our backbone, and we have valine. Moving on to leucine, we're going to incorporate this branch, and we're going to make an L for leucine because its single letter abbreviation is L for leucine. So we make this L, and then this long branch of the L right here, we're going to split it in half with another line, and that gives you leucine. Isoleucine, its single letter abbreviation is I, and when we add it to the backbone, we're going to draw an I for isoleucine, only we're not going to complete the horizontal parts of the I. So we're not going to draw this part or that part. So we'll do this, and there's our isoleucine. So it's kind of half an I. Methionine is a little bit trickier. Its single letter abbreviation is M, and to draw methionine, we start with our background. We start with our backbone, and we draw an M. And you'll kind of have to use your imagination here, but let's switch colors. You can see this right here is an S. So this is a bit of a stretch, but you connect your M to the backbone, and you've got your sulfur, a carbon here, and of course the beta carbon, and that's methionine. So we'll draw it again real quick. We have S there. That is methionine. So I know that one is a little bit of a stretch, so I'll do it one more time. And then we connect our M to the backbone, and we have our sulfur there, our carbon here connecting to the sulfur, carbon here connecting to the sulfur, and then the connection to the backbone. Proline, its single letter abbreviation is P, and what you'll have to remember about proline is it is cyclic, and it completes its 5-membered ring by bonding with the nitrogen of its own amino acid. So this one's also a bit of a stretch. It might just be easier for you to memorize, but proline, we're just going to draw a big P going through the N to kind of help us. So there, a big P for proline, and we know it's going to be a 5-membered ring. So we have one member. Let me switch colors. We have one member, two member, the third member. So we just need two more to form a 5-membered ring. So we'll put one here and one here, and there we have proline. Phenylalanine has a single letter abbreviation different than its first letter because P is already taken by proline. So phenylalanine, its single letter abbreviation is F. So you kind of stress the pH in phenylalanine. And we've already drawn alanine, and you should know by now what a phenyl group is. So all you need to do is add a phenyl group and connect it. So if we were to draw all that out, we would have our benzene, and we just connect it to the backbone, and that's our phenyl group. So this gives you phenylalanine. Tyrosine is another one you're going to have to memorize. Its single letter abbreviation is Y. You can't really work that in, but all you need to remember is it is a hydroxylated phenylalanine. So again, we'll draw our phenyl group, and we just add a hydroxy group. And if we were to sketch that out, we would have our benzene ring, and the hydroxy group is at the para position. So that is tyrosine. So you know alanine, you can build phenylalanine, and then you just need to remember that tyrosine is phenylalanine with the hydroxy group. Tryptophan has the single letter abbreviation W. So this one is a bit to work in, but it's manageable. The other thing to remember is that it's a benzene ring combined with a 5-member ring that has a nitrogen. So, as we said, tryptophan is W. So you just draw a W and turn the right-hand side into benzene, and the left-hand side we know is going to have a nitrogen, and it's going to be a 5-membered ring. So we just complete the structure, and there we've got our 5-membered ring. Fill in our double bonds, and then we just connect it to our backbone. So this is actually, we have our beta carbon here connected to this carbon of our indole group, and that gives you tryptophan. So I'll draw it one more time. Tryptophan is W. Draw our big W, add our benzene, our nitrogen, fill in our double bonds, and connect it to our backbone. Though it helps to put the W a little off center, so you can go like this, and you can make it clear that we have that carbon here, so it doesn't look like we're just going right from the alpha carbon to here, because we have that beta carbon in between. All right, next up is serine, and its single letter abbreviation is S. This doesn't help with anything, you're just going to have to memorize it. Serine just has hydroxy group attached. End of story. Next up is threonine, and its single letter abbreviation is T. So to work T in, we just turn our backbone into a T, and we have our hydroxy group. Or you can think of it as a serine with an extra methyl group attached to it. Although, for me, I just like thinking of it as a T, and you just have to remember that threonine as an alcohol attached.